Good morning, students. So here we continue the fifth part of the first chapter, force. So here are some of the topics that we will try to discuss today. The first one is gravity. Second one is acceleration due to gravity. Third one is derivation of expression g, that is g equal to gm upon r square. And similarly, we will also try to study the variation of value of g on different places of earth, and also we'll try to do or solve some numericals by using the given formula of acceleration due to gravity. So first of all, we'll define gravity. The force by which heavenly bodies attracts small objects towards their center is called gravity. The force of gravity on a body of mass is given as F is equal to m into g. Here we have written the word or the term towards their center. Why is it like that? Okay. uh, to discuss this, we'll take an example. Okay, suppose two men are in a competition of rope pulling. Okay, let us suppose one is very strong, tall, whereas other one is very weak and short. So when both of them will pull each other, definitely it is sure that the man who is tall and strong will pull the man with short and weak towards him. Okay, here both men are pulling, but the one with the strong pulls the weaker towards itself. So same is the condition in gravity. Actually both the planet and any other object, okay, they both mutually attract each other, but what happens, the attraction of small mass is not seen, whereas the attraction towards the bigger mass is seen. Okay, we cleared it from the example that I gave you just now. Okay, so you can say that gravity is the effect of gravitational force. Okay, and since we know the distance in a gravitational force is from their center, so here the heavenly body or the planet will also attract objects towards their center. Okay, now I have given one question that may be asked in exam, which is differentiate between gravity and gravitation. Okay, so first of all, in first we can write the definition of both. Okay, similarly in second step we can write their formula. Okay, so the formula of gravitation force is F is equal to gm1 times m2 upon d square, whereas the formula for gravity is F is equal to mg for a body with mass m. Okay, and like we discussed earlier, the cause or of this gravity is gravitational force. So we can say gravitation force is cause and gravity is its. Okay, now next definition we'll be studying is acceleration due to gravity. So we'll define it like this: the acceleration produced on a freely falling body due to gravity is called acceleration due to gravity. It is denoted by small g, and its average value is 9.8 meter per second square on earth. Okay, so here we have used a term free fall, which we are going to discuss in detail later. Okay, so why I have written here the average value of g. So why is it like that? Okay, it is because the value of acceleration due to gravity is different at different places of earth. For example, at poles it is 9.83 meter per second square, and in equatorial region it is 9.78 meter per second square. And the value 9.8 meter per second square that we use is the average value of g throughout the earth. Okay, so we'll discuss this topic detailedly later on. Okay, one reasoning question that can be asked from this topic is: the acceleration due to gravity of earth is 9.8 meter per second square. What does it mean? So you can write its answer like this: it means that when an object falls freely under the effect of Earth's gravity, its velocity increases by 9.8 meter in every second, which means if your velocity of falling in first second is 9.8 meter per second, in second second it will be 9.8 plus 9.8, 19.6, and again in third second it will be added by 9.8, which will be 29.4 meter per second, which means in every second the velocity will increase by addition of 9.8 meter. Our next topic is derivation of expression for acceleration due to gravity. Okay, so for this we have to make a figure. Okay, so let us suppose the circular figure over here is Earth. Okay, and its radius is r, its mass is given as capital M, and an object is there, okay, whose mass is given as small m. Okay, now according to Newton's law of gravitation, force is given as F is equal to G m1 times m2 upon d square. Okay, so here m1 is mass of Earth, so we'll write capital M. M2 is mass of the small object, which is given as small m, so we'll consider it as small m, and the distance between their centers is the radius of the Earth, so we'll write here capital R square, which will become our equation 1. Okay, so I have underlined here some sentence. You may skip that, okay, while making notes in the copy, or you can write, no problem. Okay, so the equation we got, F is equal to capital G capital M small m upon capital R square, will be our first equation. Now again, according to Newton's second law of motion, which we have studied in class 9, it is the force is F equal to m into G. Okay, so here in the slide, force is the product of mass and acceleration, so magnitude of gravitation force on the body, m is given by the product of its mass and acceleration due to gravity is given. Okay, and I have marked it, so if you want to write it, you can write, or you can skip this sentence. Okay, so you can directly write, according to Newton's second law of motion, F is equal to mg, which will be our second equation. Okay, so here we got two equation. First one is F is equal to gmm upon r square, and second one is F is equal to mg. Since both are force, we can equate them. Okay, so when we equate equation 1 and equation 2, we get mg equal to g capital M small m upon capital R square. Okay, so what is common on both sides? Small m, so we can cancel the small m in both sides, so our final answer will be g equal to capital G times capital M upon R square, where G is universal gravitational constant, M is mass of the Earth, and R is the radius of the Earth. Okay, so this is the formula that is used to find the acceleration due to gravity of a planet. Here's a question. I have solved it by using the equation that we found just now. The question is like this: the mass of Earth is 6 times 10 to the power 24 kg and its radius is 6400 km. Calculate the value of acceleration due to gravity on the surface of Earth. So first of all, we will write what is given. The first thing given is mass of Earth, which is capital M, equal to 6 times 10 to the power 24 kg. Similarly, radius of Earth, that is capital R, equal to 6400 km. And we already know that while finding force or solving this equation, we have to convert it into SI unit. So the SI unit of length is meter, so we'll convert it into meter. So it will be 6400 times 1000 meter equal to 6400000 meter. Now acceleration due to gravity small g equal to what? We have already derived the formula, which is g equal to capital G capital M upon capital R square. Okay, so we know the value of g, 6.67 times 10 to the power minus 11 times mass of Earth is given 6 times 10 to the power 24, and radius of Earth is also given 64,000,000 whole square. Okay, so we'll multiply here like we did in the earlier classes. Okay, we'll multiply smaller term with smaller, so we'll multiply 6.67 times 6, which will be 40.02 times the power of 10 will be multiplied 10 to the power 24 minus 11 upon the square of 64,000,000 whole square will be 40.96 times 10 to the power 12. Okay, now when we divide 40.02 by 40.96, it will be 0.977 times, and when we take this 10 to the power 12 above, it will be 10 to the power 13 minus 12. In next step, it will be 0.977 times 10 to the power 1. Okay, so when this point is shifted towards right, it will be 9.77 meter per second square, or you can round it off and make 9.8 meter per second square. So others numerical will be doing in next class. So if you have any doubt, you may ask me on my WhatsApp number. Okay, thank you.